All right, questions here on section 2.8, number 27 and number 28. So in this section, they're asking you to draw the graph of a function. And let me hit their important, the thing we're going to draw has to be a function, guys. It has to pass the vertical line test. It's got to be on the interval from 0 to 4, so that's all I've included on the graph so far, and the properties given in each one. So in number 27, they want us to draw a function here that has infinite one-sided limits at x equals 2 and does not satisfy the conclusion of the intermediate value theorem. Okay. So as soon as I read the phrase infinite one-sided limits, that makes me think that we're talking about a vertical asymptote here when our limit at a finite value is infinite. And in fact, in number 28, same thing. Infinite one-sided limits at 2, so that one is also going to have a vertical asymptote. The difference between the two is that in number 27, we want this function to not satisfy the conclusion of the IVT. So here's what I'm going to do, guys. I'm going to draw, does it really matter? Sure. I'm going to draw, no, I take that back. It doesn't really matter. We're able to freehand this thing. So I'm going to draw a function here that does something like this over here on the left-hand side. And then on the right side, I'm going to make it do something like this and go with that. Now, what I really have drawn, and I guess maybe I thought about doing this, I will now, I've kind of drawn this thing with one horizontal asymptote applying on the left as x approaches negative infinity, and another horizontal asymptote applying over here as x approaches positive infinity. Now, we were supposed to just consider a function defined on the interval here from 0 to 4. So that means I probably drew a little more of this than I needed to. But if I start the function at this point right here when x is 0 and end it at this point right here when x is equal to 4, here's the issue here, guys. This function right here starts at a particular x value, and I'm just going to make up a number. I'm going to say this begins at a point 0, 1. So my y value right there is 1. And then down here, let me say then that this point at the end here is going to be 4, and then maybe a y value of negative 1. Now, I guess I should be consistent right here. Okay, that's the point 0, 1. Now, if this function satisfied the conclusion of the intermediate value theorem, then every y value in between 1 and then this negative 1 right over here would have to occur in the function at least once. But for example, right here at 0, that is a value that this function never reaches in between the x values of 0 and 4. You kind of have this vertical dead zone right here between the two functions. So not every y value between its starting y value of 1 and its ending y value of negative 1 occurs in this function. So I think I did what we wanted to do in 27. I think we drew a function that's it's defined from 0 to 4 right here. It's got infinite one-sided limits at 2, a positive infinity as it approaches 2 from the left, but then it approaches negative infinity as it approaches 2 from the right. And this function here does not satisfy the conclusion of the IVT. Then for number 28, I'm going to do almost the exact same thing, except with one major change. So I'll move this one up a little bit higher. So I'll make the left side do something like this, but now for the right side, I'll make it look like that. And now here, guys, let me just play around with some ideas. I'll do some different values here so I don't confuse you. Let's say here we're starting at the point 0, 3. Let's go with that. And then over here, all right, gotcha, we're going to end this thing at the point 4, and I'm just going to make up a value here. Maybe that's 5. Okay, now guys, what this one would mean, the conclusion of the intermediate value theorem would tell us that every y value in between 3 and 5 has to occur at least once. So between 3 and 5, we're looking at this range right over here. All of these values, let me switch colors on you here, do occur. In fact, they all occur twice, once right here and once right here, and that would be the same here as well. That one occurs and that one occurs and everywhere in between. And I guess really the real reason here, guys, that this one works out, the function that I drew on the left-hand side, right, would be a 1-to-1 function. It passes the horizontal line test, but the one in number 28 that we drew is not 1-to-1. So that just might be an interesting little consideration, not anything that's super important. But okay, your graphs for 27 and 28 might have looked different than that, but these two do what they were asking us to do on those two problems.